area of a regular polygon. So last time, or time before that, we got our formulas, and we talked about area of a regular polygon is 1/2 apothem times perimeter. And the one we worked, I gave you the apothem, I gave you a side length, and you worked it out. So we're going to start with that, and then we're going to have to work some where you're not given all the information. You have to find it. All right, the distance from the center of a polygon to any side is called the apothem. So this distance right here, center to side, is called the apothem. The apothem always cuts the side of the shape in half. So it's always going to cut here and bisect, and it's always going to be perpendicular. The radius of a regular polygon is the distance from the center to a vertex. So this is your apothem, this is your radius. So think about your polygon inside of a circle. Your apothem is going to the side, so it doesn't reach the side of the circle, but your radius would reach the side of a circle. Okay, so look at the difference between apothem and radius. Formula is 1/2 apothem times perimeter. So if I give you like number 1, I give you the side length, I give you the apothem, easy cheesy lemon squeezy. So to find the perimeter, we're going to do 24.2 times 3, because this is a regular polygon, meaning it's an equilateral triangle. All sides are the same. All right, somebody's going to take out a calculator because I can't do all this in my head. So you've got 24.2 times 3 for your perimeter. What is 24.2 times 3?
72.6.
72.6. So 1/2, apothem is 7, perimeter is 72.6. So 254.1. And we got to put feet squared out to the side for area. Any of your area should be squared. Okay, so 1 and 2, those are easy. You find the perimeter, you multiply 1/2 apothem times perimeter. All right, go down, and let's go down here, number 3. So sometimes you're not given all of the information you need, and you're going to either use trig or special right triangles to find it. Now, there's only going to be probably 2 of these on the whole test. So this, I mean, it's a little bit harder, but I think you can do it. All right. They gave me the apothem, but they did not give me a side length. Okay, I don't have the side of the hexagon. So, step 1. Draw a hypotenuse from the center to the vertex. So you're drawing a radius, which creates a right triangle. Now, just because I would like for it to be bigger, I'm going to take and I'm going to draw this triangle over here. Just so you can see it better. And that's 5, right? Well, ultimately, I need this right here because I need to know what the side of the triangle is. I mean, the side of the hexagon is to get the perimeter. Okay, going back to last chapter. How many degrees is this angle right here in a hexagon? And if you don't know, how do I find it? How do I find out how many degrees are inside?
Oh, you gotta do the. No, it's the first thing. It's like n minus 2 times 180 divided by 60, 360.
So n minus 2 times 180 divided by n. Remember that from last chapter? That's going to tell me how many degrees that is right there. So we're going to do 4 times 180 divided by 6. So how many degrees is that right there? 120. So this whole angle is 120 degrees. But when you draw this hypotenuse right here, it cuts that angle in half. So this angle right here, instead of being 120, is going to be 60. This is going to be 60 degrees. So what kind of triangle do I have?
60,
30, 60, 90 triangle. So in this particular problem, is 5 the short, the long, or the hypotenuse?
Long.
The long. And the long is x square root of 3. So this is x root of 3, 2x. Remember that? So we've got to work this out to figure out what x is. So basically 5 equals x square root of 3. We're going to divide by the square root of 3. So x equals 5 divided by the square root of 3. But we can't have that in the denominator. What do we do again?
times the square root of 3.
Times the square root of 3 over the square root of 3, which is 5 square root of 3 over 3. Okay? So 5 square root of 3 over 3 is this guy right here, which is this guy right there, just from here to here. So is that all the way across the hexagon or halfway?
Halfway.
That's halfway. So to get the side length, we've got to double this. So instead of 5 square root of 3 over 3, it's going to be 10 square root of 3 over 3. So the side length of that hexagon is 10 square root of 3 over 3. How many sides does a hexagon have? 6. So to get the perimeter, we're going to do 10 square root of 3 over 3 times 6 over 1. Go way back to like 5th grade. Remember how we can cancel these? No. Like, remember we can make this a 1 and we can make this a 2?
Yes. Yes, I remember that. That's canceling, not canceling.
Yes.
Yeah, it is.
Very good.
Okay.
So make that a 1, make that a 2. So what is 10 square root of 3 times 2? 20. So the perimeter is 20 square root of 3. Okay, so we did all that work to get the perimeter. So now we're going to plug it into the formula. 1/2 apothem, which is 5, times perimeter, which is 20 square root of 3. It doesn't matter which one of these you have. You can have the 5 or have the 20, but don't have them both. Well, it's easier to have 20 because that's an even number. So half of 20 is 10. 10 times 5 is 50. So the area of this is 50 square root of 3 meters squared. 50 square root of 3 meters squared.
I did not.
That's a lot. Okay. Let's try another one. Let's do number 4. What shape is number 4? A triangle. It's an equilateral triangle. So the apothem is 18. So we're looking for the perimeter, so we need the side length. So step 1, draw this down like that. How many degrees is each angle in an equilateral triangle? 60 degrees. But when I drew that purple line, I cut that 60 in half, right? So this little guy is 30, correct?
Yeah.
So I still have a 30, 60, 90 triangle. It's just a little bit different than this one. Is 18 the short, the long, or the hypotenuse? The short. So it's the x value. Do you need the hypotenuse or the long? The long. So what is the long value?
18 square root of 3.
18 square root of 3. So this guy right here in green is 18 square root of 3.
So times 6.
Well, technically yes, but let's just do it times 2 just so we're on the same page. So if this is 18 square root of 3, I double that to get the whole side. So the entire side length is 36 square root of 3. And it has 3 sides. So the perimeter is 36 square root of 3 times 3. All right, what's 36 times 3?
108.
108. So that's going to be 108 square root of 3. So I have my perimeter and I have my apothem. So 1/2 apothem times perimeter. Since these are special right triangles, we're going to leave the square root of 3 instead of multiplying it out. So you're just doing like half of 18, so 9 times 108. And just leave the square root of 3 on it. 972 square root of 3 millimeters squared. Okay, I'm going to go to the back. I want you to try one. So go to number 8. 8 is a hexagon, correct?
Mm-hmm.
So it's going to be a lot like number 3. But what is the difference on 8 that you're looking at on your paper and number 3 that we did?
There's no dotted
You have the side length. You don't have the apothem. Okay? So we're going to do the exact same way. You're just looking for a different piece of the puzzle. Okay? So number 8, we'll get you started, and then you're going to work it on your own. So same thing. I want you to draw that right triangle in there.
How do we know which way to draw it?
It doesn't matter. You can draw it any way you want because all the sides are the same.
Wait. Never mind.
Now, 22 is all the way. So for the triangle that we're using, what are we using? For this little piece.
The short.
No, like 22 is all the way. For the triangle, how long is this?
11.
Half, 11. So for this triangle, you're just using 11. All right, so using the one we did on the other page, number 3, take a minute and see if you can find, you need this right here. So figure out where your 30 and your 60 go.
Just find that or find the wrong.
Let's find that first, and then we'll.
Well, that.
If you think your apothem is correct and you want to keep going and find the area, that's fine. Okay. So, how many degrees again is this whole thing?
I did nothing with that. So
Well, tell me what you did.
Well, the short is x, and that's 11. Would it not just be 11 squared root of 3?
Okay, but I'm asking if I was starting this problem from scratch. I'm on the test. I haven't worked.
I don't know that it's.
Like how I need to know how to decide how many degrees I'm using. So it's a hexagon, right? Okay. So how many degrees is that angle right there? 120. Which means this angle right here is how many?
120.
60. Which means that this angle right here is 30. Betsy, I know you knew that because we just worked one like that, but I want to make sure we know how to get that.
That makes sense.
Okay.
I just assumed.
So that's my short. So you assumed correctly. So that's 11. So the apothem is what? 11 square root of 3. This one was actually easier because we have the short versus the long. So we didn't have to divide by the square root of 3 on this one. All right. So the perimeter is 22 times 6.
How'd you get 6?
Because it has 6 sides.
Oh, dumb.
So that's 132. 1/2 apothem times perimeter. 1/2 apothem times perimeter.
Where did you get the 132?
22 times 6. So that should give you 726 square root of 3 yards squared. Did you leave the square root of 3 in your answer?
That's 104. 132.
132
1/2
times
of 132.
is 66 times 11. Okay. All right, we're going to do one more of these, okay? Now, out of the whole test, you're only going to have like 2 of these, okay? So we shouldn't be like worried that this is going to be the entire test. Okay, I want you to go back. I want to go to the pentagon on number 5. Go to the pentagon on number 5. Okay. So I'm going to draw this right here. So step 1, draw your line. Now we have to figure out how many degrees that angle is.
So, divide by n, or, so, 108.
So 108. So this is 108, which means that this one is 54, because it's always half. When you draw that hypotenuse, it's always half. Now, is that a special right triangle? Mm-mm. So that means we have to use SOHCAHTOA. So your options will either be special right or SOHCAHTOA. All right. So I want this, because I want the side. You're not ever looking for the hypotenuse, because that's not helpful. You're either looking for the apothem or for the side. So using 54, is 10 opposite or adjacent?
Opposite.
Opposite. Is what we're looking for opposite or adjacent? So we're doing tangent. So tan 54 equals opposite over adjacent. What do we do when x is in the denominator?
We put tan at the bottom.
We switch them out. So in your calculator, you're going to do 10 divided by tan 54, 7.26. Is that all the way across the pentagon?
No.
No, it's halfway across. So some of you have realized, well, I could just multiply that by 10. But if you don't realize that, or why I'm saying 10, well, halfway across is 7.26. So you could technically just multiply that by 2 to get all the way across. Okay?
I have a question.
Okay.
Okay, how did you get 108? Like,
N minus 2 times 180 divided by n. The formula you used on the last test to find the interior angles of a polygon.
oh,
N minus 2 times 180 divided by n. Okay, so the length of the side is 14.52. I doubled 7.26. So to find the perimeter, I do 14.52 times 5. Or some of you have already done this. You just multiplied this by 10. That's fine. So the perimeter is 72.6. 1/2 apothem times perimeter. And you should get 363 inches squared. Is that not what you got?
no, it isn't. But I don't understand why I can't calculate anything today.
Did you?
I got 360. Why am I 3 off? Oh, it's 72.6, 7.2. Wait.
It's 72.6.
I'm not doing it. I don't want to do this.
Okay, so step 1, draw your hypotenuse. Step 2, calculate your angle measures by using n minus 2 times 180 divided by n. Half that when you get over here because that's only half of that angle measure. If it's a special right triangle, use special rights. If it is a non-special right triangle, then you're going to do trig. Okay? All right, we're going to do one other thing today. It's actually much easier. Okay? Much easier.
I'm about to fall asleep.
Hit yourself. So you're going to see this on ACT a lot. All right, so Miss J's favorite food is pizza. I love a pizza. Now, I eat the whole pizza. So I don't really need to know the area of a sector. But Betsy might only eat part of a pizza, so she wants to know the area of just part of the pizza. Okay? How much cheese she's eating. All right. So a sector is like a slice of pie or a slice of pizza. So a sector is a part of a circle that is bounded by a central angle. You should remember that from the circles chapter. A central angle right here. And its intercepted arc, which is right here. So it's the shaded part. It has the central angle, and it's got this little intercepted arc. Now, we're going to learn also today, also besides area, we're going to do arc length. Like how far is that? So if I have this big circle that's 11 miles long, but Micah only wants to run this far, I want to see how far he's running. So we're going to do 2 formulas today, area and then area of a sector and then arc length. All right. Think of a sector like a slice of pie, pizza, whatever makes you happy there. Okay. To find the area of a sector, how many total degrees is in a circle?
36.
So when I find the area of a circle, I'm finding 360, 100% of it. But if I have this little shaded part, This may be 40 degrees, 50 degrees, 60 degrees. It's like a pie chart. To find the area of the sector, I'm going to do x, which is the angle measure, over 360 times pi r squared, which is the formula for area.
Is this gonna be our test?
So angle measure over 360 times pi r squared. That's for the shaded part. I want you to come over here to the side and I want you to write arc length. So what if I want to find how long this is, how many miles this is of the circle? Around the circle is circumference. What's the formula for circumference? Formula for pi times d. So for arc length, we're going to do x over 360 times pi d. So this is for area. This is for arc length, how far we're running. All right, so go to number 1. We're going to do 2 things. We're going to find the area of the sector, and then we're going to find out how long, how far we're running from A to C. So that's arc length. Okay, got 51 degrees. So you're going to do 51 over 360. The radius is 16. So pi r squared. So this says round to the nearest hundredth. Let's just leave it in terms of pi. So let's just leave pi in our answer. So in your calculator, if you're using the big calculator, do control divide. 51 divided by 360 times 16 squared. And just don't type the pi in the calculator, and we'll just put pi in our answer. So 51 over 360 times 16 squared. Elizabeth?
I got 36.3.
36.3. So it's 36.3 pi feet squared.
But that's just for like the central angle, right?
That is just for the shaded part, the gray shaded part. Say that again? No, that is if I were painting that gray part. From A to C, we're going to do the same thing, but instead of area, we're going to do circumference. So we're going to do 51 over 360 times pi d. So if the radius is 16, what's the diameter?
8. Sorry.
Try again.
What's 6?
32.
32.
Yeah. Oh.
So we're going to do, diameter is double the radius. So 51 over 360 times 32 pi. All right, so you're going to do 51 divided by 360 times 32. So that's going to give you 4.53 pi. And these are just going to be feet because that's just like the distance of that piece. So area is if you were painting this area gray. Arc length is how far is this arc if I were walking around a track or driving around a track or whatever.
But if you want to like get the whole thing, can you just add those together? Like add that area? No, wait, no. You'd have to find the perimeter of the shaded region to do that. Actually, no, you wouldn't. Never mind.
Okay. All right, so I want you to do number 2. I want you to find the area of the sector, and I want you to find the arc length. And we're going to do those. We're going to check this and do one more problem today. And you can just leave pi in your answer.
So don't put pi on here.
Right.
I got a really big number. You, Betsy? Oh my God.
So you should have done 139 over 360 times 22 squared times pi, but we're not typing pi in. So I got 186.88 pi. (186.88 pi centimeters squared.
I made this one for
I'm just doing 2 for right now. What'd you do?
you.
Okay, that's the area. For arc length, so Bryce wants to run from P to R. She wants to know how far it is. So we're going to do 139 over 360, but we're doing circumference. That's pi times d. So double your radius, 44 pi. And I got 16.99
I got
centimeters. Now, Betsy, if you had rounded to the 10th, you would have to round that up to 17.0. Because that 8 would round up to the 9 would round that up.
I'm not figuring it out.
All right. Can you do one more? All right, last problem. Go to the back real quick. And I want you to go to, oh wait, actually I don't think it's on the back. I thought it was. My fault. Go to number 4. I'm still looking for the area of the shaded region, the gray part. But what did they give me differently than the other ones?
The region,
The non-shaded part. So I don't want to use 126. So how am I going to get this measure over here? 360 minus 126. So if they give you the non-shaded part and you want the shaded part, you're going to have to do 360 minus 126. What is it? 234? So you're going to do 234 over 360 times 13 squared pi. 29.85 pi.
Yes.
All right, and then if you want the arc length, how the distance from G to I this way, we're going to do 234 over 360 times 26 pi.
I got 16.9, so would you round that out up to 17?
No, you can leave it as 16.9. The other one we rounded because it was like 16.99. And if we were rounding to the 10th, it would round it up. Okay? All right, so these are a little bit easier. We should be able to do these. On the test, you're going to be able to either leave it in terms of pi or do it as the 100th. I'm going to give you the choice.